This is a DIY smart bird feeder. It's fully 3D printed and has a built-in 5-megapixel camera that detects birds, sends alerts, and stores footage locally, all without any subscriptions. It's also solar powered with a modular design so you can customize it however you like. In this video, I'll walk through how this feeder came together and how you can build one yourself. This idea started a while back when I got this bird feeder shaped like a picnic table, and it's been surprisingly fun watching different birds show up in my backyard. I started looking into smart bird feeders with built-in cameras, but most of them were pretty expensive and some of the newer ones even lock useful features behind subscriptions. So instead of buying one, I wanted to see if it was possible to 3D print my own by integrating an outdoor security camera to be able to view birds. I originally planned to design the feeder from scratch, but after some searching, I found a 3D model online that already had a great design and was a perfect starting point. It supports a variety of cameras and is pretty modular so you can customize it to your own liking. And so I downloaded the files and got started on the project. After doing some research, here are all the components I gathered to build the feeder. For the camera, I decided to go with the Reolink Argus 3 Pro. It has a 5-megapixel camera, offers features like night vision and motion detection, and stores everything locally without any subscriptions required. I also plan to integrate this camera with Home Assistant and add some smart features later, which made it the ideal choice. The camera is also battery powered and comes with a solar panel. Based on its specs, it should last a few weeks on a full charge, which makes it convenient so I don't have to run a power cable to my backyard. For the camera, we also need a microSD card for local storage, and I'm going with a 64GB card, which should be more than enough. To print the feeder, I picked up some PETG filaments from Prusa Mint. Since this will be outdoors, we need something durable, and PETG is perfect because it's UV resistant, waterproof, and can handle outdoor temperatures. For the color scheme, I went with Signal White, Anthracite Gray, and Chalky Blue, but you can pick any colors you like or keep it all one color to save on costs. And finally, we'll need a few hardware pieces, 4 M4 screws with nuts, 2 M3 screws, and some outdoor screws to mount both the feeder and the solar panel. As always, you can find links to all the components in the description. With all the components ready, I imported the 3MF files into Prusa Slicer and prepared them for printing. The original print file only includes a camera mount for the Amazon Blink, but there's another print profile with additional mounts. Here, I found a camera mount for the Argus Pro, but based on the dimensions, it looked too big for the Argus 3 model I have. I needed to design a new camera mount, so I first took some measurements of the Argus 3 Pro. Then I used FreeCAD to design the new mounts, and this is the final result. The corner geometry is similar to the Argus Pro, so I was able to simply scale down the edges to get a proper fit. For the back plates, I added an extension to account for the thicker body of the Argus 3 Pro. I also added an opening large enough for the USB-C cable, angled downward to prevent rain from getting inside. Once I was happy with the design, I sliced all the models, grouping them by the filament colors, and sent the files to my new Prusa Core 1 Plus. This video is not sponsored, but Prusa provided this printer to help support the channel. This was my first project with the printer and I was excited to give it a try. As a beginner in the 3D printing hobby, it was really easy to get it up and running, and I'm really impressed with their open source ecosystem and upgradable components. I'm really excited to use this printer for future projects and look forward to partnering with Prusa. For the colors, I went with white for the main body, gray for the camera mount and backplate to complement the camera, and blue for the roof and perch to add a pop of contrast. Altogether, it took around 14 hours to print all the models. Before moving on to the assembly, we'll need to first set up our camera. I started by opening the rubber flap and inserting a microSD card into its slots, then flip the power switch on. Next, I installed the Reolink app on my phone and followed the setup wizard to add a camera. This involved scanning the QR code on the camera using the app, which I had removed earlier, not realizing was needed. Then I set up my Wi-Fi credentials and scanned the QR code with the camera itself. Once that was done, the camera was ready to go and we had a live feed up and running. Now we can move on to assembling the bird feeder. I'll begin by attaching the main body to the pole supports. On the bottom of the feeder, there are 4 mounting holes. I'll drop an M4 screw into each one, then I'll line up the pole support underneath and hand thread the M4 nuts to hold everything in place. Once all 4 are on, I'll tighten the screws with a screwdriver while holding the nuts steady with a pair of pliers to make sure everything is nice and secure. Next, I'll install the threaded set screw. It screws into the hole on the side of the pole support piece, which will tighten the feeder onto the wall mount once it's outside. With the base assembled, we can move on to the camera. The Argus camera slides into its mount and sticks out slightly from the front. Then I'll run the USB-C cable from the solar panel through the slot in the back plate and plug it into the camera. Once everything is connected, I'll hold the pieces together and slide the entire camera assembly into the feeder body. After that, I'll take the roof piece and snap it into place at the top of the main body. To finish things off, I'll attach the lid and handle using two M3 screws and close off the roof. Finally, I'll take the front porch and snap it into place on the edge of the feeder. And with that, the bird feeder is fully assembled and ready to go outside. To install the feeder, I chose a spot in my backyard that gets plenty of sunlight so the solar panel can stay charged. I'm mounting it to my fence, but you could also use a pole, a tree, or even clamp it to a balcony railing using additional mounting parts from the model files. I'll start by securing the wall mounts to the fence post using 3 outdoor screws. Then I'll attach the solar panel mounts to the top of the fence post. Once that's done, I can place the feeder onto the wall mount and attach the solar panel to its brackets. I'll tuck the cables neatly behind the fence so they're out of sight, then tighten the set screw to secure the feeder. And with that, my feeder is ready for some feed to start attracting birds. For the feed, I'm using the seed mix from Amazon, which seems to be popular with the local birds. I removed the roof and went ahead and filled the feeder with the seed mix. Now, all that was left was to wait for birds to show up. And within a day, I already had the first visitors. When I checked the footage in the app, I noticed a big issue. The birds were completely out of focus. Because this is a security camera, it wasn't designed for close-up shots that I was going for. After a bit of research, I found a Reddit post in the Reolink subreddit that suggested using this close-up lens from Wise. It was around $15 and seemed worth a shot, so I ordered one and gave it a try. It came with a strap that slips over the camera and it seemed to fit nicely over the camera's lens. I also modified the mount so the camera sits slightly lower to get a better view of the birds. While I was at it, I also made some improvements to the feeder. I noticed when it rained, the roof didn't fully cover the base, causing some of the feed to get wet. Apparently, others faced the same issue, so the designer of the feeder had a scaled up roof, which I printed and swapped in. I also added the external perch that extends from the base, giving the camera a better view of the birds. It includes a small water dish, which is a nice addition to give birds a source of water. With these updates, the feeder was finally complete. The close-up lens made a huge difference and birds are now much clearer in the footage. Here's a quick compilation of the different bird species that have stopped by so far. This ended up being one of my favorite projects so far, and I really enjoyed building something that benefits the local wildlife. I already have a few follow-up ideas in mind, like a smart birdhouse with a built-in camera, or setting up bird species detection. Let me know what you'd like to see next in the comments. If you enjoyed the video, don't forget to leave a like and subscribe for more videos like this. And a quick shout out to Michelle, the creator of the bird feeder model on MakerWorld. Thanks for watching, and I'll see you in the next one.